question types for midterm. Yeah. So now we need to prepare for the midterm. Okay. All right. Yeah. 2 weeks from Thursday. 2 weeks from Thursday. March 21st, midterm. Yeah. After spring break. Next week, spring break. Yeah. So, yeah. All right. So we need to prepare for midterm. Yeah. So today I give you some basic information about midterm. So what kind of questions I want to give you, the arrangement. Yeah. All right. So first, the midterm. Yeah. So here, the specific day, March 21st, Thursday. Yeah. All right. Yeah. Oh, yeah. All right. All right. Yeah. So now, so let me give you the basic information. So the questions. Yeah. So our midterm questions. Total 25 questions. The style, the format, similar to our homework assignment number 1. Okay, homework assignment number 1. Yeah, yeah. I will give you homework assignment number 2 soon. Yeah. So you have spring break. So probably at the end of spring break, you submit by the end of the spring break. So then I grade it. So then Tuesday I do review. Thursday you do midterm. Okay. Yeah. All right. So the style similar to that of homework number 1. Okay. Number 1, number 2, same style. Okay. All right. So for midterm, these 25 questions, I plan to arrange these 5 questions in this special way. Yeah. Because think about, if I ask you to do these 25 questions in class 2 hours, can you complete it? No way, right? Yeah. Realistically, no. Although they are old questions, I won't give you. Basically, I ask you questions based on homework assignment 1, assignment 2, quizzes, but I just, rephrase the sentences, right? Same content, same rules, but I change a way to ask you. That kind of things. Yeah. So other than, for some computation questions, you have seen, you have solved, similar old questions, but now you just do some modified version of the questions. Yeah. So I won't give you brand new questions. Brand new questions. Yeah, completely different. Yeah. So all the questions are modified. Okay, here and there, conditions, yeah. Yeah. In that way. Yeah. All right. Yeah. So these 25 questions. All right. 2 parts. I split it in 2 parts. Part A and a part B. Okay? Yeah. Part A, I put 10 questions in part A. Okay? So what kind of questions? These two types of questions. Yeah. Multiple choice and true and false. Only these two types of questions for part A. Okay? Yeah. 10 questions. Yeah. All right. Now, the way to deliver these 10 questions, I want to save your time. Yeah. So I do not ask you to do these 10 questions in our official test time here. Okay? So you do these 10 questions at different time. All right? So what different time? You do these 10 questions. Yeah. Remember now, you are doing quiz 2, right? You are doing quiz 2. After quiz 2, you will do quiz 3, right? Quiz 3. All right. Quiz 3, I plan to give you 10 questions of the same types. Same types. Yeah. So now, I merge these two. All right. So part A, the same as quiz 3. Part 3 equals quiz 3. Yeah. All right. After you turn in quiz 2, I will post the quiz 3 quickly. Okay? I will post quiz 3 quickly. So you have about 1 week to complete it. Yeah. Approximately 1 week to complete quiz 3. Yeah. But when you do the quiz 3, that's the same as our part A of midterm. Same. So I counted twice. Okay? Quiz 3, I counted once. Then in midterm, same score, I copy from your quiz 3 and put in the midterm, part A. Yeah. All right. For those two types, multiple choice, true and false. Okay. Part A. Part B. Yeah. Part B, 15 questions. Okay. Now, problem solving. Yeah, you need to write solutions. Yeah, you need to, solutions. 15 questions. Yeah, these 15 questions. Two types. Okay? Yeah. The first type, solving ODEs. Yeah. Including that initial value problem, IVP. Okay? Yeah, solving ODEs directly. Okay, all right. First type. Second type, word problems. Word problems. Okay, yeah. Solving ODEs and initial value problem, I plan to give you 7 questions. Okay. Word problems, 8 questions. Okay. All right. Yeah. So total 15 questions. At 21st, Thursday, when you're here 2 hours, you work on these 15 questions. Yeah. How do you feel about this plan?
So part A is not quiz 3, but it's very similar to quiz 3?
Is quiz 3.
Okay, part A is quiz 3.
Same as quiz 3. Yeah. So I just use it, counted twice. Okay. Yeah. Yeah. All right.
It seems obtainable.
All right. Yeah. All right. All right. A little more. Yeah, because I see your face expressions. Yeah, I understand. So, yeah. All right. Then. All right. Yeah. Okay. Furthermore, all right, try to help you a little more. All right. So part A, let's say question numbers from Q1 through Q10. Q1 through 10. Part A. Yeah. Then part B, questions from Q15, Q11, Q25. All right. All right. Then further split, another round splitting. Yeah. All right. In class. Yeah. So that is March 21st, Thursday, that day, okay, 2 hours period, 6 p.m., 8 p.m. All right. Yeah. Yeah. So you have the question numbers from question 11 through question 25. Okay, so when you see I print out, pass the test paper to you. The first one is question 11. Okay, yeah. 11, 12, that. All right. Then I split in another 2 groups. Yeah. Yeah. A little complicated, yeah, but not too hard for you. Question 11 through question 20, 10 questions. 10 questions. Must be completed in class. Okay? All right. Question 21 through 25. Yeah. All right. When you get home, you have a second chance to work at home. Okay. How about that?
Yes. Right. Yes.
Second chance. Working. Is it much better at home?
I'd rather them be switched.
And sorry?
And then so they'll be due on Thursday then?
Not Thursday. Yeah. Weekend.
Weekend.
All right. All word problems, all right? All these 5, all word problems. Because you need more time for word problems, right?
Yes.
Yeah. So due due
Yeah, no homework.
end of weekend, the same weekend, right? End of weekend. Okay, so you have extra time. Okay, extra time. So in class, you spend most of your time on those 10 questions. Okay, so you do not have to spend your time on last 5 questions. Yeah. Only, because some students really good, after they solve 10 questions in 2 hours, they have plenty of time complete the, last 5. Yeah, that's good. You just do it. Okay. Yeah, but I put instruction so you have second chance. Remember, yeah. Manage your time in a smart way, right? Manage your time in a smart way. So, because at home you have a lot of time to, the last 5 word problems. Okay, yeah. So that's the whole plan. Okay, yeah. Any question? Yeah. Yeah. The coverage, module 1, 2, 3. Yeah. Module 1, 2, 3. Yeah. All right. Yeah. Oh, another thing to help you prepare for the midterm. Yeah. Because I like to help you a little more preparing for the midterm in this way. Yeah. All right. In those 15 questions, 2 students, I just noticed that. So let me get them in. Yeah. All right. Yeah. All right. Yeah. So another thing, I plan to help you a little bit, especially during the spring break, when you study, for the midterm. I want to help you on these 15 questions. Yeah. 15 questions, 7 here, 8 here. I will tell you what's the specific type of questions for those 7. All right? Yeah. 1, 2, 3, the type, question type. And I give you a sample questions. I give you a lot of exercise questions. I just take that exercise question, the same type, I put there, right? Put there. I can even copy the solutions. Just I make a PDF file. Okay, PDF file. These 15 questions, 1, 2, 3, 4. Type 1, type 2 solutions. You study. All right. Yeah. So for your convenience, although you can find, right?
Yes.
If I tell you, although you can find, but I compile them, put the same file. You just study that file, PDF file. Okay. All right. For these 7 questions, 8 questions, word questions, I can also do in the similar way. Yeah. Similar way. We have many different types, right? Mass string, system, electric circuit, right? Spring, whatever, type 1, 2, 3, right? Yeah. So I select, all those types. We cannot cover all. I just select 8 from them. Okay. So when you do prepare, you focus on those types. All right. Yeah. Hope in that way, so it's not that scary, right? Yeah. Yeah. That's the plan. Yeah. 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 Because I noticed some students, they worry a little bit. Yeah, so they worry about, midterm. Yeah, definitely. Yeah, definitely. Yeah. Yeah. All right. Yeah. So that's all I can think of related to the midterm. Yeah. Yeah. All right. Yeah. So you study, but you understand the details, because I need to modify. Okay? I need to modify, something. Sometimes it looks the modification is a little big. Okay? Yeah. Yeah. All right. Yeah. So here, for example, the modification. Yeah. So here I want to give you an example of modification. Yeah. Let me use this previous slide, but I need some space. Yeah. All right. Yeah. So remember, in your homework assignment, question number 2. Yeah. I talk about it in class. Yeah. So you are given a question like Pxy equals, yeah, so let me write something like an, yn, right? Yeah, I mean, approximately, yeah. So as I remember, something like this. An minus 1, sorry, yeah. A1, y, A0, right? Yeah, so given this polynomial, now I ask you to solve ODE in this form. So I ask you, about the separable, right? 3 options. First one, always separable. Second option, never separable. Third one, sometimes separable, sometimes not separable. Yeah. So here, I use this example to let you know how do I modify this question. Yeah. In a test, in a midterm, I will give a similar question. So let me tell you, how do I modify? Okay? All right. The way the modification. Yeah. So here, and in this question, I will give you. All right? Yeah. In quiz 3, I give you through quiz 3. Yeah, because multiple choice. It should be part A, quiz 3. Okay? Yeah. All right. So here I show you the way of modification. Yeah. All right. So for the modification, I define another polynomial, qxy. Okay? P and a Q. I call it Bn, Yn, Bn minus 1, B1, Y. Okay, same format, but we change the coefficients from A array to B array. How about that? Okay. B0 xm. Okay. All right. Now I ask you to solve differential, ODE. This time, Px over Qxy. Okay. Yeah. Then I ask you the same 3 options. A, always separable. B, never separable. C, sometimes separable, sometimes non-separable. How about that? That's example. Okay. That's the way of modification. So here you can see, although the modification, but it may not be very easy, right? So you really need to do some important work, at least not non-trivial work, non-trivial. Think about this, okay? Yeah. And you will see it in quiz 3. Yeah. Okay? Yeah. All right. Okay, so let's move to our Part D stuff. Yeah. That's all about midterm. Yeah. So you have more questions, just let me know. Yeah. All right. Yeah. Yeah. All right. So Part D, qualitative methods, face plane. Yeah. In this part, we do something quite different. Yeah. So we do not really solve ODEs. Yeah. The reason is sometimes the ODE could be very hard to solve. Yeah. So we're not able to solve directly. Yeah. 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 So there is an option people can do some qualitative analysis. Yeah. So we try to do some analysis to see some properties, yeah, to collect some information, so that can help you, get a better understanding of the ODEs. Yeah. So you have some special view on those ODEs. Yeah. Yeah. Later, so after you get a better understanding, then you can choose, some other ways. If we want to solve, we know there is a numerical way to solve. Yeah. If we really want to solve, so we can use, computer programs, computer software, and but we need to set up. Yeah. You need to do the setup work, set up for the numerical solution. So then you feed into the software. So then you run the program software, you get a solution. Yeah. So that's another way. Yeah. So I hope this class I can find some time to show you a few examples on numerical solutions. Yeah. 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 We have one chapter for that. Yeah. All right. D.1. Trajectories in the face plane. Yeah. So we draw graphs. Here you can see we draw graphs. From the graphs we want to see, some special properties. Yeah. For some of the ODEs. Yeah. All right. Here, the first example, this one, electrical network. Yeah. The question is not hard. Yeah, actually we solve it. It's an old question. Yeah. Here I just take the solution here and we draw graphs, yeah, to view differently, yeah, from the graph. Yeah. All right. So that's our old equation, initial value problem, and I copy the solution here. Yeah. I1, I2, two solutions. Yeah. All right. Now, next question. We can draw the graphs. I1 graph, I2 graph, as a function of t. Each one a function of t. Okay? Yeah. All right. Set two separate curves. These two separate curves. So you can see, like that. Yeah. All right. So you can get some information from the graph, how the electric current change. Okay? So, convergence, right? Convergence. Yeah. Yeah. All right. But other than that, yeah, because these two currents, they are in the same system, same linear system. Yeah. So So we want to get information, these two currents, what is the correlation between them? Correlation. Yeah. So they change because they always change together, right? Together. Yeah. Yeah. So there should be some correlation. Yeah. So this time we want to take a different view on these two currents. Mainly we want to look at their correlation. Yeah. Every time, at time t, yeah, each time t, two current numbers, what's the correlation of those two numbers? Yeah. At every time t. So what's the certain special relationship, yeah, between those two numbers? Yeah. All right. So here we take this view. We view the role of t, we treat it as a parameter. T is a parameter, yeah, underlying parameter. Okay. Yeah. Here it's visible. Yeah, we can see t. Visible. Yeah. All right. Then we make it underlying parameter. Hidden, you cannot see t. Yeah. Hidden. Yeah. We just want to see the relationship between I1, I2 directly. Yeah. All right. How to view in that way? We treat the two currents as a parametric curve. This term, parametric curve. Okay. Yeah. So I think you have experience. You saw some parametric curves before, right? Yeah. So let's review the concept parametric curve. Yeah. Yeah. I believe you view. Yeah. When you learn calculus, yeah, especially when you learn calculus, so you saw some parametric curves. Yeah. So let's study this parametric curve, this concept. Yeah. All right. In mathematics, a parametric equation defines a group of quantities. Yeah. All right. A group of, here we have three, our group, I1, I2, as functions of one or more. Yeah. So you can have three. In 3D, you can have a 3D curve. Okay? I1, I2, I3, 3D curve, and so on. Yeah. Independent variables called a parameter. The t is independent variable, parameter. Yeah. All right. Parametric equations are commonly used to express the coordinates of the points that make up a geometric object, such as a curve called a parametric curve. Another important case, surface. I didn't put it here, yeah, because surface. Here we do not look at the surface. Okay, but surface is another parametric with parametric surface. Yeah, we just call parametric surface. Yeah. More complicated. Yeah. Here we only do the parametric curve. Look at this example. X of t equals cosine of t. Y of t equals sine of t. It's a parametric curve. Yeah. The shape, you can see the shape, it's a circle. It's a circle. But we write a circle, we have many different ways to write a circle, right? Yeah. Here, this way, parametric way, parametric equation to write a circle. Yeah. All right. Another way we know x squared plus y squared equals 1. Yeah. 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 Here, in the xy plane, yeah, here you see we draw the curve in the xy plane. Yeah. Here, can you see? Yeah. So here, I like you to use this example to see some difference. Yeah. All right. Yeah. Yeah. Before we look at our current question, yeah. So I like to, explore this example a little more. Yeah. First, if we look at the plane, t coordinate, x coordinate, this cosine curve is like this, right? This is a cosine curve. Okay? All right. Then, if we draw sine curve, t-axis, y-axis, so your sine curve is like this. Right? Yeah? Okay? Yeah. Now, all right, so that's one way we view x and y. So one way we view using these two separate, we look at them separately. Two separate graphs. Two separate graphs. Now you can see we take parametric curve way. We want to see the correlation between x and y. Now you can see the circle. There we cannot see circle, right? If you view separate, how can you see there is a circle relation between them? You cannot see. No. But when we convert these, the same equation, but this time we make that parameter t some hidden parameter, so we can get an equation x squared plus y squared equals 1. So that is a unicircle. So here we draw this unicircle. So you can see this view gives you some information you cannot see from that separable way, right? Separable view. Yeah. So that's the point. Yeah. Here, now we want to do the same thing. So although we can view each current separately, yeah, but now we want to view these two functions together and want to see their, when t changes, how these two values change in a special pattern. Yeah. So that's what we want to see in this new view. Yeah. All right. So let's draw the parametric curve here. Okay? This is the parametric curve. See? Like that. Okay? Yeah. Yeah. The change. Here, t is hidden. You can, from here you have I1 axis, I2 axis. Yeah. The t is hidden, so you walk along this path. T is reflected, along this path. You need to take that t, okay? That t. Yeah. Yeah. So there, the curve is like this. Yeah. Trajectory. Yeah, that's the trajectory. So we want to study. Yeah. Try to see some new information. Yeah. That's the qualitative method. So we study in this topic. Yeah. All right, so let's continue. Yeah. Try to see more. Yeah. All right. All right. So here we call this I1, I2 plane phase plane. Yeah. Phase plane. Yeah. All right. The curve trajectory. Trajectory. Yeah. But that is one trajectory, right? One of the trajectory. Yeah. Yeah. In the, because here, why here it's only one? Because here this is only one special IVP problem, right? Yeah. Can we change the initial condition to get another I1, I2 solution? When we change initial conditions. Yeah. Yeah. So we get another trajectory. Okay? So when we use so many different initial conditions, so we can get a lot of trajectories. Yeah. So all those trajectories we can draw, on this I1, I2 coordinate system. All possible trajectories. So we get a phase portrait. Here, phase portrait. So that concept. Containing all trajectories. All right. Here, so we get a better qualitative overall impression of the general behavior of the solutions. Because the older way it's hard to see this kind of general behavior. So here we take this new way to see it. All right, so let's see. Face portrait. Here I'm talking about the face portrait. All right. Here I didn't do animation, but this slide not very complicated. So let me explain this slide a little bit, because next slide I will explain the trajectory clearly. Because here, how can you see this kind of trajectory, right? It's hard to understand. So the hard part is this: how to understand the trajectories in this graph. The solution is not hard. Remember, that's the same solution we solved last time, right? So actually, this is an old solution. If you recall from the notes last time, basically I just copied the old solution. So here the homogeneous solution is like this. This is the homogeneous solution. So we do the eigenvalue, eigenvector, the standard way to find eigenvalues, eigenvectors, homogeneous solutions. Then we write y1, y2 functions explicitly, but we have C1, C2 parameters. Now, when we change specific values for C1 and C2, every time when you select C1 value, C2 value, you can draw one trajectory, right? Then you take a different C1, C2 values, then you draw another trajectory. So you draw all the possible trajectories, you get this picture. Like that. You get, each one is one trajectory, The question, so here, the harder part is, how can you see trajectories like this? Can you understand, Jenny?
No.
Yeah. So on our textbook, display that, no further explanation. So how can you understand this trajectory? How can you understand the trajectory? So, So on my next slide, I will explain one by one. Because here there are several different types of trajectory. So I do one by one. So we take different values for C1, C2. Then you can see we get a different types of trajectories. All right. So let's see it. Oh, I didn't do the animation. All right. Very messy. All right. Let's do it this way. Because it's near the break time. Can we do break time early? At this point, then we continue at 7. How about that? So I fix the animation. This one. Sorry. But we just do it this way.